Okay, so next we're gonna see some other types of graphs and charts, and the first one is stem and leaf plot, and it is very interesting, and it gives us a very good understanding of the data. It helps us to explore the data. That is also it is a part of the exploratory data analysis, which is an analysis to explore the data. And let me show you how it works. So if you remember, we were working on this data set, which was about the ages of students. So if you look at this data, this shows you that each and every data value consists of two digits. There is one stem and one leaf, again stem and leaf. Okay, so you can have data values other than these. For example, you can have a single digit data value. 07 is basically 7. So there is one, uh, you know, stem and then leaf. Okay, and you can have three-digit values where the last one is always the leaf and the rest is the stem. You can have 105.6 where 0.6 is basically the leaf and 105 is the stem. Okay, so the last digit is always the stem, or last digit is always the leaf and the rest of it is stem. So how can we convert this data set into stem and leaf plot? Here we have converted the complete data into stem and leaf plot. You can see that we identified the stems first, and we see that there is no single data value in the data set that starts with 0. The lowest value is 18, which starts from 1, and then the stem is 2, 3, and then we have 4, and then we have 5. So these are the stems 1, 2, 3, and 4, and 5. Okay, next we so that we actually, for example, if these are the values and 32 and 49 and 51. So we had values in data set and we strike down the value and then we write down the leaf in front of the stem. So here you can see there are 1, 2, 3, 4, 5, 6 values that actually has a stem of 1, which means that these values are between 10 and 19. Okay, so 18, 18, 18. There are 3 18s and 3 19s, right? Then you have more values with the stem of 2, and then you have a little less values than the 2 stem values, which fall in 3 stem values. Then you have 3 values in stem 4, and there are 2 values with stem 5. And if I draw a vertical line here, so you can see that you can observe the trend, a bar graph here that shows you that where there are more values and where there are less values. So it is a kind of tilted histogram, as well as the histogram shows you all the values of the data set, right? So here we have 220s, 321s, and then 22, 24, 27, and 229s. Okay, so this is how you look at the data values as well as the trend in the data, that which stem has more values and which stem has the lowest number of values, right? So this is how you can explore the data through stem and leaf plot. This graph allows us to see the shape of the data as well as the actual values. So the one major benefit with stem and leaf plot is that it helps to look at actual values of the data set, right? So you can also divide the stem into 2 classes. For example, you can put the values from 11 to 14 in the first stem, and the other values from 15 to 19 can be put into, we can put them into second stem. So you can see that we have divided each stem into 2 parts. The half part is the first stem and the half part is the other stem. So we have 2 stems of 1, 2 stems of 2, 2 stems of 3, 2 stems of 4, and 2 stems of 5. So this can also give us a little more insight into the data, that where we have more values and where we can have less values. Okay, so we divide one stem into 50-50 percentages. Then another very interesting exploratory plot is called dot plot, where we have a horizontal axis, a horizontal line, and which starts from the lowest value and it goes up to the highest value. And then we put a dot on the numerical point number line, on the number line wherever the point exists. For example, if you remember, we had three 18s, so we have three dots on 18, and then we have three values on 21 also, and three values on 19 also. Okay, so you can see there are no other three values at the single point in the data set. So this is also an exploratory analysis of data, that where actually the values lie. So one further, way of actually preparing this line is that you can manually write down the actual values here. Instead of writing down the dots, you can write down actual values: 18, 18, 18, 19, 19, 19. So you can exactly look at the values, what are the values that exist at a particular point. Okay, and you can also see where the gaps exist in the data set. So this is one more example of a good way of exploring your data set. Then we have a pie chart. I don't recommend to use pie charts because they are very vague. They're very difficult to manually construct. Although software can help you to construct a very simple pie chart, I would suggest that if you have only a couple of or three or four categories, only then you use a pie chart. Otherwise, it can be very cumbersome to understand a pie chart. Here you can see we have categorical data here, and then we have a quantitative information regarding these categories. So we can put them in the form of a pie chart. So first of all, you find out the relative frequencies. As earlier we have used F over N formula to calculate these frequencies. Same formula is basically given here to calculate the relative frequency, and after calculating the relative frequency, you multiply that with 360, because 360 degrees are the total number of angles in a circle, in a pie. So we divide that 360 with the relative frequency, multiply with the relative frequency to come up with the particular angle that we are going to use to construct the uh, the what do you say, the part of the pie that we are going to use for this particular category. Okay, so these are different wedges. This is the wedge for motor vehicle, which is 57.8%, and then you have another wedge for the falls, which is 16.2, and so forth. Okay, this is the pie chart. Right. So next chart is very interesting, which is Pareto chart. Pareto chart is again a bar chart. This consists of different bars, but they are arranged in descending order, which means the tallest bar comes very first, and then you have the shorter bar, and the shortest bar comes at the very end, right? And this is also based upon categorical as well as quantitative variable. We put the categories on the x-axis, and we put the numerical values on y-axis. So here you can see that we have different categories on x-axis, and we have their frequencies of quantitative values on y-axis. The highest bar comes first, then you have the shorter bar, and then the shorter bar, shorter, and the shortest comes at the end. Okay, so this is a descending order. You will see this downward trend in the bar. Right, so why this is important? This is based upon a rule called 80-20 rule, that 80, if you solve the major 80% problems, the rest of the 20% problems, they get solved by themselves. Or another way of interpreting it is that most of the issues make up your 80% of the top problems. First, you solve them. For example, if we have different kind of problems regarding a particular system categorized downwards here, you will see that one particular problem will consume the 80% of those problems, which would be the highest number. So if you solve that one, the system would gain most of its health. All right, so this is how you use Pareto chart. So next chart is scatter plot, and this plot is very important in understanding the relationship between two variables. Here you can see that we have two variables, both are quantitative variables. And if we talk about these particular variables, they're about students. If a student has more absentees in the class, it will have a lower final grade. So you can see a downward trend of these dots. Now, for example, we had around 1, 2, 3, 4, 5, 6, and 7 students, and we collected the information about their absentees, and then we actually got their grades. And we saw that students that had a lower number of absentees, they had good grades. And students that have more absentees, they had not that good grades, right? So this downward trend is visible from scatter plot. That means there is a relationship between these two variables, and it is a negative or inverse relationship. That means increase in one variable actually shows you the decrease in the other variable. And there are other types of scatter plots. For example, you can have upward dots, and that would show you a positive or direct relationship. That means one variable increases as well as an increase in the second variable is observed. All right, or maybe the dots are so much scattered that you cannot actually locate a trend in them, which means there is no relationship between X and Y variables. All right, so one more type of graph which actually you have seen in cricket matches or maybe in laboratory observations that relates to time. And you see the change in a particular variable in relation with time. So the chart that we use for showing that trend in change in that particular variable is called time series chart. And for example, you can see we have a data where we have months, and with those months we have a corresponding timing in minutes. So we can just put this information about the cell phone usage of somebody in minutes throughout the year in months, and you can see the trend through time. This is a trend line again. And this time this chart is called time series chart because it is based upon time. As time increases, you see the change in this variable, which is cell phone usage, and we express this change through minutes. All right,